Solve the following inequality and graph the solution. So to solve a quadratic inequality, what we have to do is test intervals. So the first thing in order to test these intervals is to find the zeros of the polynomial. So this is in factored form, so changing the factors into zeros is easy. Just take the opposite of each value. So -7 and +10. Now, we're looking for the inequality to be bigger than 0, so that means I'm going to go ahead and put those zeros in as open circles on my solution. That's going to be part of the answer. What I have to determine now is the solution going to be in between these values or outside of these values, or which intervals qualify to be greater than 0. So to do that, I pick test values. And the test values in each range here, I can pick any value in this range that's less than -7, and all of these values are either going to be positive or negative. So for instance, the smallest test value that I can choose here would be -8. Now if I put -8 into the original polynomial, it would be -8 plus 7, which is -1, times -8 minus 10, which is -18. So the product of these two values is positive. So what that means is all the values on this region right through here are going to be positive. So we shade that. Next, the test value within -7 to 10 that's easiest to use would be 0. So plugging 0 into my polynomial, I would have 7 times -10, which is a negative value. So everything on this interval is negative. We're looking for positive answers, so we don't include this interval. Lastly, I'll choose 11. It's the smallest in this range. So 11 plus 7 would be 18. 11 minus 10 is 1. So 18 times 1 is a positive value. We are looking for positive values, so everything in this range is included as a solution. So the solution in interval notation is the range from -infinity to -7, but not including the -7, union 10 to +infinity.